Hello everyone, in this video we're going to implement selection sort. So what is selection sort? Well, it's a sorting algorithm that sorts an array. So we can have an array with all the elements in some random order. We use the selection sort algorithm to sort our array. So we're going to implement selection sort in this video and then generate a random array that we're going to use to test it. So over in Eclipse, I've created a new project called selection sort and create a new class that's also called selection sort with no main method this time. So what we're going to do is define our own method called selection sort. So public static void selection sort, and this is going to take in as a parameter a double array, and we're going to call it list. So what actually goes in here? Well, I guess we need to think about how selection sort actually works. And what it does is, if you imagine this is our array, and we have 3, 5, 7. I shouldn't make this in order. 3, 7, 5, 11, 2. Just any random numbers. What selection sort does is this. It starts off, it uses two for loops, an inner and an outer for loop. The outer for loop starts looking at this element here. Then our inner loop iterates over all of the other values in the array to find the smallest one it can. So after this time through the loop, this is the smallest number. Now, if it found a number that's smaller than this one at I, it swaps them. So the next time through the loop, it swaps these numbers. So we end up with 2 and 3. And then I moves to here, and we continue sorting. So just quickly, let's do a real life example of this with a few less numbers. So let's say 7, 4, 11, 2. So this is our array. And I starts here. We loop until we see the smallest number, which is going to be 2. So at the end of this iteration, we have 2, 4, 11, 7. And we start looping from here. So 4 is already in its right spot. So by the time we get to here, we don't have to swap anything. So at the end of this iteration, we have 2, 4, 11, 7, just like before. And we end up with I here. Now, we loop through this again, and you can see that 7 needs to be swapped with 11, so it does that. So 2, 4, 7, 11, and then we're finished. So that's how selection sort works. How do we implement this in code? Well, the first thing we're going to do is have our outer for loop. So for, and we're going to have a variable called I equals 0, and we're going to loop to the end of the list, at the end of the array, so list.length, and we're incrementing I each time through. So the first thing we're going to do is store the current min. So double current min equals list at I. So whatever element we're starting at, we're going to call that the current min for now. Now it's also not enough to just store the value of this. We also need to know whereabouts in the array it was. So int current min index equals I. Now comes our inner loop. So for int j. Now remember that if I is equal to here, we start looping on the inner loop. Oops. We start looping from here, which is I plus 1. So in our code here, we're going to have int j equals I plus 1. J less than list.length, and again, j plus plus. Okay, so what goes in here? Well, all we need to do is check whether the value in the list at position j is less than our current min. If it is, then we update it. So if current min is greater than list at j, then we're going to update current min. Current min equals list at j, and we also have to update the index. So current min index equals j. And that's all that goes inside our loop, our inner loop anyway. Once we've done our inner loop, we have to decide whether we swap. And the way we do this, so the way we decide whether we swap is whether current min index does not equal I. So, because at the start here, we set the current min index equal to I. Now, if we found a smaller number, that means that we've changed this index. So that's how we're going to decide whether we need to swap. So if current min index does not equal I, then we do a swap. So list at current min index is going to equal list at I, and list at I is going to equal current min. And that's all there is to it for selection sort. It's a really, I guess, kind of simple algorithm to get your head around. But what we should probably do now is test this to make sure it works. It's all well and good for me to say it's simple, but if we don't test it, who are you going to trust? Not me. I'm just going to maximize this now so we've got a bit more space. Let's create a main method. Public static void main string array args. Now what we're going to do in here is generate randomly a double list. So first thing we're going to have is double array numbers equals new double, and I'm just going to put in 5 in here. So we're going to generate five numbers inside our array. Now we're going to have a for loop. So for int I equals 0, I less than numbers dot length I plus plus. What we're going to do in here is assign each value in the array to a random number. So numbers at I equals math.random. And just to make things a bit easier for us to see, we're going to multiply this by 100. Now what we're going to do is, while we're going to print out this array. So system.out.println. Actually, not println, just print. We're going to print out numbers at I, and then a space at the end. So we separate the numbers. And that's it for that loop. Now what we're going to do is just have an empty println statement, which is the same as printing a new line character. The next stage is we're going to sort our array. So we're going to call selection sort on numbers. So that'll sort our list. And now what we're going to do is print out the array again just to make sure they sorted. So I'm going to copy and paste this for loop and then get rid of this assignment. So our new for loop only prints out the numbers. So that is enough for us to be able to test this code. So let's bring the Eclipse UI back and run it now. So run as Java application. Now you can see here, so this first line is our unsorted array. We have 56, 51, 71, 2, and 72. So this is clearly not sorted. However, our second loop, which is after we've called sort, is definitely sorted. We have 2, 51, 56, 71, and 72. So we can run this again. We'll get different numbers. So 20, 59, 96, 51, and 46. And after the sort, we have 20, 46, 51, 59, and 96. So our selection sort is certainly working, which is fantastic. So just to summarize now, selection sort finds the smallest number in an array and then places it in the first position of the array. It then goes on to find the next smallest and places it in the second position. This continues until we get to the end of the array. So to do this requires two loops, an outer loop and an inner loop. What this means is that the amount of work that has to go into sorting our list grows very rapidly as our list gets bigger. But that doesn't matter just for now. And finally, we tested this implementation with random values, and we found out that yes, it certainly does work. So that's it for this video. Thanks a lot.